Hello everyone, welcome to a new day, a new lesson. Today, as you can see, with all these shapes on the screen, we are talking about a few more shapes, squares, rectangles, parallelograms, and triangles to be more specific. And we're talking about area, perimeter, and everything to do with these with these shapes. So I hope you have your notes printed and you're following along. Let's get started. Like I said, the objective is to be able to calculate the area and perimeter of squares, rectangles, parallelograms, and triangles. And a lot of this is easy. It's review. You know squares and rectangles especially. I mean, that's super easy. The point, though, that we're kind of reviewing and focusing on them one by one is because in a day or so, we're going to be combining all these shapes into something else. And so you need to have this solid and be able to find the area of these shapes before we can do that. So for today, we're just going to be finding the individual area and perimeter. All of these are going to have formulas. And remember, the whole resource for this unit is that formula chart that you were given, the STAR formula chart that you will also have on your STAR test, on any test. That chart has these formulas. So you don't necessarily have to memorize this, but I'm telling you it's simple enough to where these formulas are going to stick in your head. So let's get started. Let's talk about those formulas first. So for each of these squares, we're going to write the formula right here to the side. First of all, I keep saying squares. For each of these shapes, all right, the area of a square, as you know, I'm just drawing a little square out here. You never know. Some of us may have forgotten what a square looks like. The main feature of a square is that every side is the exact same, right? We do these little hash marks. That's a square. The area of a square is area A equals base times height, b times h. Little b, little h. Now there is another way we can write this. It's up to you. The one that I just gave you, base times height, that is the official. It's on the formula chart. But we can also say that this is area equals length times width. Length times width. It's the same thing. It's just using different terminology. And you may have heard both of these in the past in 6th grade. All right, next one. Area of a rectangle. Remember, rectangle. If I can draw one out here. There we go. That's good enough. An area of a rectangle is A equals, again, base times height. Or we could do that same change in terminology again. Area equals length times width. Very easy stuff, guys. So far, so good. Now let's talk about parallelograms. This rectangle is bothering me. Let me fix it. Okay, a parallelogram is just a rectangle that's kind of tilted over like that, like a side. It's just been like smushed to the side, kind of. Either way, the formula stays exactly the same. It's base times height. Or again, we can use that second terminology, which is length times width. Why are those three exactly the same? Well, because those shapes are what we call a square, rectangle, and parallelogram. They are quadrilaterals. This is not stuff you need to know. I'm just giving you an explanation. Quadrilaterals, meaning they have four sides. All of them have four sides, right? And so they kind of follow that same pattern of the area formula being the same. These are very similar shapes. Now the triangle is going to be a little different. Here's a triangle. The triangle is area equals base times height. So that part is the same, but divided by 2. I will explain in a second why that is. Or there's another way of writing this. we can do, instead of divide by 2, there's another way we can mathematically say dividing by 2, which is multiplying by half. So we can do area equals half base times height. Now, both are exactly the same. All right, if I told you 6 divided by 2, right, that is taking half. That is 3. But if I also said half times 6, that means taking the half of 6 or multiplying 6 by 0.5, that would still be 3. Dividing by 2 is the same as multiplying by half. So it's your choice which one of those two triangle formulas you like, which one looks better for your mind. I tend to like this one just because anytime I see a fraction that's like just a big no-no for me, or at least it's just not appealing to me. Let's talk about this triangle formula and how it's related to the square or rectangle formula. Now remember, there's actually several kinds of triangles, right? Not all triangles are the same. We have what we call right triangles. We have, what's the other? We have a scalene triangle. We have an isosceles. Whatever the case may be, for any of these triangles, let's represent a triangle in a different way. Here's a rectangle. Now inside, which, of course, a rectangle has an area of base times height, right? That's the formula. Now inside of the rectangle, if we cut the rectangle diagonally, it's not a very straight diagonal, but if we cut that rectangle diagonally, what do you see inside? Aren't there two triangles inside of this rectangle? You see that? There's one on the top right here, and there's one here at the bottom. I've put them in different colors. So a triangle, there's actually two inside of a rectangle. So if you cut a rectangle in half, that's how you make a triangle, which is why the formula of a triangle is base times height, that's the rectangle part, divided by 2, and that's how you get a triangle. That's where that formula comes from. Okay, we've got our formulas, so we're ready to do a few examples of putting them, actually applying them. Here we go. Find the perimeter and area of the following figures. So, perimeter first, area second. We need to identify what the shape is. What is this shape? They're not telling you, but you should be able to identify it. It is a box where they've put these hash marks, meaning all the sides are the same. So that would be a square. For perimeter, you just need to be able to add the outside length. Remember, that's perimeter, the whole outside length. Every side, since this is a square, is 7.4, 7.4, 7.4. So you can just add that 4 times, or you can do 7.4 times 4 to get your answer. So 7.4 times 4 is 29.6 inches. Now the area. Write the formula always. Area equals base times height. The base, I suppose, most naturally we would think is there, and it is 7.4, remember, times the height, which is how tall the shape is, and that is the other 7.4. So you're just multiplying by itself. So you're going to be doing 7.4 times 7.4 to get your answer. Let's work this out. 16, 28 plus 1, that's 29. 28, 49 plus the 2, that's going to be 51. 17, 4, 5. So the decimal would go there, 54.76. The area of that square is 54.76. with the units, that would be inches squared. You always need to put squared for a area unit. Okay. Perimeter of this rectangle, which means we need to add up all of the sides, the outside length. We don't have every single length written out for us, but we can figure that out, right? Isn't that 24 at the top and 17 off to the side? So we just add everything. That would be 17 plus 17 plus 24 plus 24 added together. Go ahead and add that and compare with what I get. I got 82 centimeters. Okay, now the area, which is area equals base times height. So the base is going to be 24 times the height, which is 17, so you're multiplying those two numbers. 24 times 17, and that gets us 408 centimeters squared. Now remember, what is the definition of area? We know perimeter is the whole outside. And what is area? Just to kind of refresh your memory from a few days ago, area is the space inside of the shape. So the difference, perimeter, you were finding the length of the outside. Area, you're trying to find the space inside. So usually the area, the number for area should be much bigger than the perimeter, just as a way to check the reasonableness of your answer. Moving on. This one here, we've got a parallelogram. Now a parallelogram, let's do the easy part first, which is the perimeter. Perimeter, we've got a 9 right there, a 4. What would this length be at the top? Even though it's not written, it would just be the same as the bottom. That's going to be 9. And this length to the side, which has not been given, but it's the same as the other side. Since a parallelogram has two parallel lines, this line is parallel to this, so they're the exact same. And this line is parallel to that one. They're the exact same. Okay, perimeter is going to mean adding everything up, so it's 9 plus 9 plus 4 plus 4. I'll write that down. 9 plus 9 plus 4 plus 4. 9 plus 9 is 18, plus the 4 and the 4. That's 8. So 18 plus 8 is 26 centimeters. Okay, now area is base times height. Okay, we actually have three different numbers here. We have a 9, which would be our base, and then we have this 4, which on a rectangle would be the height, but then we have this 3.5, and so we need to pick the correct one as the height. So listen up, listen carefully, this is important. The height on these type of shapes, if there's a dotted line, that is the actual height. So this 3.5 is the height, not the 4. The 4 would just be a width. Height is always represented by a dotted line. So here we're going to do 9 times 3.5. To get an answer of, what would that be? 9 times 3.5 is going to be 31.5 centimeters squared. Okay, so that was the key there. The height is the dotted line. Height will always be represented by a dotted line in shapes that have a height. Okay. Triangle. A couple of triangle examples. Now, perimeter, always easy. Just add the outside lengths, which even though all the sides have not been given, they put those hash marks telling you that the sides are all the same. So we have a 7 there, 7 there. So we have 7 plus 7 plus 7, which is 21. Okay, hopefully I don't have to show my work for that particular example. Let's go to the area part. Area equals base times height. The base is kind of, the bottom, what it's sitting on, that's a 7. Oops, actually I wrote the formula wrong. Look at me. Base times height divided by 2, that is the area of a triangle. Let's plug in our numbers. The base is 7. The height, remember what I just told you, the height is always represented by a dotted line. So where's the dotted line? That would be this 3.5. So it's 7, let me use the same color, 7 times 3.5, and then that divided by 2. So let's do 7 times 3.5 first. That's 24.5. And then divided by 2. Let's work out this division because y'all might always need a little refresher on division. 24.5 divided by 2. Put that decimal straight on top. 12 times 2 is 24. Bring down the 5. 2 times 2 is 4. 1, 0. Okay, that's going to be 12.25. 12.25. Just remembering it before I erase. The answer is 12.25 centimeters squared. All right, last one. Perimeter of this triangle, which is just adding everything up on the outside. 50 plus 30 is 80, plus 40 is 120. Over to the other side. Area equals base times height divided by 2. What would the base be? Well, it's whatever it's sitting on. What would the height be? This time there's no dotted line, yes, but how tall is that triangle? This one's a different kind of triangle because it's a right triangle. And so the way it's been laid out, the 30, this is how tall it is, the height. So we're going to do 40 times 30 divided by 2. 40 times 30, well, that's like 4 times 3, which is 12 with the 2 zeros added. Divided by 2, this is going to be 600. Okay, so just so I don't run out of room, the answer is 600 centimeters squared. Alright guys, that wraps up those 4 new shapes we talked about. And really, squares and rectangles are nothing new. Maybe the parallelogram and the triangle. Every single one has a formula. You don't have to ever memorize. Have these notes or have that chart. If you have a question, look up the formula. Plug in the numbers. And the only way you're going to get good and really like natural at doing these is to do examples and some practice on your own, which is what your homework's going to be. So I hope this is clear and sticks in your head. All right, good luck. See y'all next time.